Hi everyone! Today we'll be learning how to graph the sine function with transformations. So we will work with y equal to 4 sine of 3x plus pi over 2 minus 1 and y equal to negative 2 sine of x minus pi over 3 plus 1. So let us keep in mind the general form of a sine function, which is y equal to a sine of bx minus h plus k. So a in this equation is the amplitude, b is from the period, which is period equal to 2 pi over b, negative h is the phase shift, and k is the vertical shift. Now let's work on the first function, which is 4 sine of 3x plus pi over 2 minus 1. So as you can see, our functions differ in amplitude. One is positive and one is negative. Let's see what that will give to our graph. So first, let's try the first one. We have to remember the general graph of sine. So we can write it by using 0, pi over 2, pi, 3 pi over 2, and 2 pi. We know that at 0, sine is also 0. At pi over 2, it's 1. At pi, it's 0. And at 3 pi over 2, it's negative 1. And then at 2 pi, it's again 0. So the values on the first line is 1, the midline is 0, and the bottom line is negative 1. That value at the bottom line should be negative 1. Okay, just to repeat our function, it's y equal to 4 sine of 3x plus pi over 2 minus 1. Now let's see that the effect that the amplitude gives to our sine function. So as you can see, we have to multiply it to the value of sine. So that means that we can multiply 1 by 4, so that's 4, and then 0 by 4, which is 0, and then 1 to negative 1 to 4, which is negative 4 as well. Now that's the effect that the amplitude gave to our function. Now for the vertical shift, so it will affect the value of these functions. So from 4 it will become 3, from 0 it becomes negative 1 because that's 0 minus 1, and then from negative 4 it becomes negative 5. So we can say that 3 is our top line, and then negative 1 is the middle, and negative 5 is the bottom. So negative 1 will be our midline here. So now let's determine the start and end of our function. So what we can do is equate the term inside the sine function to 0, because we know that our graph starts at 0. So that will be 3x plus pi over 2 equal to 0. Here we can subtract pi over 2 on both sides of the equation, and then we will get 3x equal to negative pi over 2. By dividing both sides equation by 3, we will get a value for x, which is negative pi over 6. That means that our graph will start at negative pi over 6. Now let's try to determine the end of our function. So that's 2 pi, right? So we have to equate 3x plus pi over 2 with 2 pi. I mean, it's not the end of our function, it's the end of our period. So what we can do is subtract pi over 2 from both sides, and that will give us 3x equal to 3 pi over 2. And now if we divide this by 3, we'll get a value for x which is equal to pi over 2. Now what we want is to write this one with the same denominator as the first one so that we won't be confused about the point. So let's write 3 pi over 6. So that's the end of our period. Now the middle one will be the middle of negative pi over 6 and 3 pi over 6. So the middle would be pi over 6. And then between pi over 6 and 3 pi over 6, that's 2 pi over 6. And between negative pi over 6 and pi over 6, that's 0. Now we can write our function here. We can just copy the one at the top so it looks like that. Now let's plot the points we got earlier. So for negative pi over 6, it's negative 1. For 0, it's 3. For pi over 6, it's negative 1 again. And then for 2 pi over 6, it's negative 5. And then for 3 pi over 6, it's negative 1. Now let's try graphing one with a negative amplitude. So that's negative 2 sine of x minus pi over 3 plus 1. So let's start with graphing our original function. So at 0, it's 0. At pi over 2, it's 1. At pi, it's 0 again. At 3 pi over 2, it's negative 1. And at 2 pi, it's 0. So that now, since we have a value for amplitude which is negative 2, what we should do is multiply negative 2 to these values. So for the first one, from 0, it will still be 0 because 0 times negative 2 is 0. For the second one, it will become 1 times negative 2, so that's negative 2. For the third one, it will still be 0. For the fourth one, it's negative 1 times negative 2, so that will be positive 2. And then for the last one, that's 0, so multiplied to negative 2, that will still be 0. As you can see here, our function was flipped when we multiplied it to a negative amplitude. So that means if we have a negative amplitude, our function will flip. Now let's try working on the vertical shift. Now that we have this with the amplitude, let's go to the vertical shift. So what we have to do is just add 1 to this. So from 2, that becomes 3. From 0, it becomes 1. And from negative 2, it becomes negative 1. And then what we have to do now is look for the functions, for the value of theta, value of x rather, where it will start and where it will end. Now that's x minus pi over 3 equal to 0. So that's plus pi over 3 on both ends, and x will be equal to pi over 3. So it will end at 2 pi, so that's x minus pi over 3 equal to 2 pi. So if we add pi over 3 to both sides of the equation, that will become 2 pi over 2 pi. If you convert it with the denominator of 3, that will become 6 pi over 3 plus 1 over 3, that will become 7 pi over 3. So that means one period ends at 7 pi over 3 and it starts at pi over 3. Now we can just write the values of x in between. So we can write 4 pi over 3 at the middle, and then between 4 pi over 3 and 7 pi over 3, that's 11 pi over 6, and between 11 pi over 3 that will and 4 pi over 3, that will become 5 pi over 6. Now let's try to graph our function. So it will be better if we express all the denominators of our values for x to 6 so that we can have an easier time graphing the function. So our midline is at 1, and our graph will look like this.